This is Quideo 3, and this is the basic question. Rotter Partners is planning a major investment. The amount of profit X is uncertain, but a probabilistic example gives the following distribution in millions of dollars. Profit 1, probability 0.1. Profit 1.5, probability 0.2. Profit 2, probability 0.4. Profit 4, probability 0.2. And profit 10, probability 0.1. So the first part of the question is asking you to find the mean of the profit and the standard deviation. So using the data that we are given right here, we can set up the mean to multiply each of these numbers in profit by their probability. So we have 1 times 0.1, 1.5 times 0.2, 2 times 0.4, 4 times 0.2, and 10 times 0.1. So then for the mean, we get it to be $300 million, or that's going to be a 3 represented on the chart. Then the standard deviation, to find that, we do the number, we use the number in profit and subtract the mean and then square it. So the first one is going to be 4, because 1 minus 3 is negative 2, and then squared is 4. And then so on until we get the values that are listed in this equation right here. And then we multiply them by the probabilities we are given up here. So then in total we get the standard deviation to be 6.35 million. And then we have to take the square root of that since it's squared originally. So we get $2.52 million. For B, the question is, Rotter Partners owes its source of capital a fee of $200,000 plus 10% of the profits X. So the firm actually retains Y equals 0.9X minus 0.2 from the investment. Find the mean and standard deviation of Y. Okay, so to find the mean, we are going to just plug it into this equation right here. So it's going to be 0.9 times the mean minus 0.2, which is going to give us $2.5 million. And then to find the standard deviation, we're going to do the same concept but plug in the standard deviation. So we're going to get 0.9 times that, and that's going to be $2.268 million. Okay, for the advanced question, it says, an insurance company estimates that it should make an annual profit of $150 on each homeowner's policy written with a standard deviation of $6,000. A, what reasons may contribute to such a large standard deviation? For an insurance company, it's going to have a large variety of profits because in extreme cases, they will have to give either policyholders a lot of money or none at all. So it leads to a very large standard deviation as there's a lot of outliers for the large sums of money. For question B, if it writes only 2 of those policies, what are the mean and standard deviation of the annual profit? So then we plug this into the equation. Mean of x1 plus x2 equals ex1 plus ex2. So that's going to be $150 plus $150, and that equals 300. So that's going to be our mean. And then to find the standard deviation, we do standard deviation of x1 plus x2 squared, and then plug it into the calculator as square root var x1 plus x2, or square var x1 plus var x2, which is going to give us to be the square root of 6,000 squared plus 6,000 squared. So that brings us to the square root of 72 million, and that gives us the number of $8,485.28 for the standard deviation. The question C says, if it writes 10,000 of these policies, what are the mean and standard deviation of the annual profit? And then we do the same thing we did in B, just with different values. And so we have to set it up mean x1 plus x2, and then that continues until x 10,000. So that's going to be the sum of the numbers ex1 equals 10,000 times 150. So that's going to give us 1,500,000. Then for standard deviation, we do the same thing where standard deviation of x1 plus x2 and all the way to x 10,000. And we get vars x1 plus var x2. And that goes all the way to 10,000. We're going to square root that. And that gets us the square root of 6,000 squared plus 6,000 squared. And that's going to be 360 billion. And so the standard deviation is going to be 600,000. For D, is the company likely to be profitable? Explain. The expected value is $1,500,000 with a standard deviation of $600,000. The z-score of $0 profit would be z equals 0 minus 1,500,000 over 600,000. And so the z-score for this data is going to be 2.5. So if the company sells 10,000 policies, they will likely be profitable. For the AP level question, it states, when a tractor pulls a plow through an agricultural field, the energy needed to pull that plow is called the draft. The draft is affected by environmental conditions such as soil type, terrain, and moisture. A study was conducted to determine whether a newly developed hitch would be able to reduce draft compared to the standard hitch. A hitch is used to connect the plow to the tractor. 2 large plots of land were used in this study. It was randomly determined which plot was to be plowed using the standard hitch. As the tractor plowed that plot, a measurement device on the tractor automatically recorded the draft at 25 randomly selected points in the plot. After the plot was plowed, the hitch was changed from the standard one to a new one, and the process that takes a substantial amount of time. Then the second plot was plowed using the new hitch. 25 measurements of draft were also recorded at randomly selected points in this plot. That's a lot of P words. Okay. For question A, it asks 3 different things. What is the response variable in this study? Identify the treatments, and what were the experimental units? The response variable in this study is going to be the amount of draft that is produced by the different types of hitches. The treatments are going to be the standard hitch and the new hitch because they're the 2 things that we are testing. And the experimental units are going to be the 2 large plots of land we are using them on. Question B says, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly in this study? Justify your answer. I said yes, it was used properly in this study since one hitch was applied to each plot of land. And there were 2 different plots and there were 2 different hitches, so it worked out. For C, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was replication used properly in this study? I said no, replication was not used properly in this study because each treatment was only applied to one of the plots. There was no replication in this study, and you would need more plots of land so general patterns could be observed. Question D is, plot of land is a confounding variable in this experiment. Sorry, I can't talk today. Experiment. Explain why. The plot of land is a confounding variable because we do not know if the draft or type of soil in the land affected the outcome of the situation and affected how much draft was produced.